Hello everyone. Today I'm going to explain to you as an extension of a wireless network, the future, the wireless communication management and control can be done by software defined radio. Uh, so in this module, I'm going to explain to you uh, not the SDR itself, but primitives. Okay. So talk will give you general idea of SDR, or in general, in many other network spectrum, they said SDN, software defined network. But for this wireless, we are working on SDR. And then we will work on categories of wireless network and some technologies, and ending with a primitive demo. So software-defined network is looking at wireless communications. Wireless communications, actually, the transmission of the data, which can be represented in bits, right? And it comes from this OSI architecture uh, from the application layer to session layer, transport layer, network, data link layer. And in the data link layer, it can be considered in two areas, link layer and MAC uh, layer. And then there's a physical layer. So through this physical layer, the application bits can be packed in a packets, and then packets will be mixed with the carrier's signal. And if there are multiple signals comes in, then multiple access. Okay, for example, CDMA, then code division multiple access, or frequency domain, frequency division multiple access, or time division multiple access, or orthogonal frequency division multiple access. So there are so many such jargons available, but it is actually based on CDMA, which we looked at in another module, right? Previous module, and and it can gain um, and it can represent it in a different voltages, different energies, so it can go into uh, the air. Okay, this is a wireless communication. What it can be generated, the applications. Okay, so it could be some image data or video data from cameras, and some data from your keyboard, some of the displays. This is more output layers. Okay, so this is for the inputs. Goes in here, then you can, in this application process, uh, and baseband, it goes into baseband processor, and then it can be um, modulated to, for example, analog front end, not necessarily analog, but digital also these days, digital communications, right? But anyway, goes into this. Uh, and Bluetooth, if it transmit, goes into also this through this antenna. And yeah, if there is any signals coming through antenna for Bluetooth signals or GPS signals, then comes in here, right? And it goes to display on speakers. Uh, this is a cell phone's anatomies, but this structure is not necessarily, well, this is of course a cell phones, but the technology techniques applied here also applied to Wi-Fi and anything about wireless network. So protocols on wireless platforms. uh, we have a source, then we have source coding. Okay, it can be MPEG formats, for example, in the application layer, and goes into transport layer, network layer, link layer, MAC layer, and physical layer. Um, and then it goes into some other process, and then finally it's transmitted over the air, right? So SDL uses a software routine instead of some of the built-in components for the physical layer. So we want to work on in this way. Okay, so it could be programmable. In this programmable, we use some of the routines already developed. So this is a more hardware printed. This is more software oriented. So this is what we need to do in SDR. There are the tiers, multiple tiers in this SDR. In the hardware radio, and then layer above that, there is a software controlled radio, and then software defined radio, and ideal software radio, and ultimate software radios. Each could be described in this way. So, for example, if we want to define some program, so this programmability extends to the entire system with the analog conversion only at the antenna. But this is the SDL that we want to look at, which is the software control of a variety of modulation techniques, wideband or narrowband operation, and security functions, etc., etc. So that is what we are looking at. So why we need the SDR? There's a seamless wireless connections to end users. It's widely different wireless protocols applied. So we can look at GSM, AMPS, and some of the CDMA techniques, and OFDM techniques also, IEEE 802.11a through N. And these technical that can support the multiple wireless protocols. And also, it can give us easy infrastructure upgrade by the coding, right? Wireless protocol evolve continually, and it is a current and future, right? So where can we use the SDR? Base station and wireless terminals. So we can give some constraints and support several hundred subscribers. And then if we want to commercialize it, SDR project, it will be the first one that you need to do. Well, wireless terminals in your cell phone, you can do more constraints on that and also commercialize. Why SDR is challenging? Must be tunable across a range of various frequencies and bandwidths. Remember that through the antenna, then we have, if we have a multiple access so that modulate it, then we have different voltages. It could be analog signals, right? So that is challenging. Well, digital baseband, of course, in this case, it is big challenges and big contributions. In our demo, what we can do is we'll use SDR with the HackRF01. You can use many others, RTL, uh, um, the radio frequency receiver, transceiver. Of course, you can do that, and also you can download in some companions, radio companion, if you want. I have this. But particularly for this module, we are not going to do real SDR coding, but simple demo. So, okay. So what we need to prepare is for wireless software-defined radio. We need to prepare a transceiver. You can work on HackRF1 or RTL. There are many different versions available. The beauty of HackRF is that it covers wide range from 1 megahertz to 6 gigahertz. So if you are using 4G cell phones or Wi-Fi, then you can see the signals. Okay, bandwidth is 20 megahertz. So in this case, right, this is what we are going to work. And antenna, in HackRF, you can have the antennas. Antenna comes with HackRF, but somehow when our HackRF, there's some reason I'm going to explain that in class. Okay. And then software HackRF1. If we want to the SDR coding, then you may be able to get GNU SDR companion. Okay, in earlier slide, I talked about that, right? But for this pre-cooked, the visualizations can be done in this SDR console. So this is what we can see. And if your transceiver communicate with your, by the way, this GNU SDR companion originally it works for Ubuntu, Linux. Okay. This console, there are many different versions available, but we are going to work on Windows versions, right? So this transceiver communicate with your computer, either Ubuntu or Windows, through USB driver. If your transceiver is not recognized by your console, then this is the software I strongly recommend you to install, and then your the device transceiver needs to be understood, needs to be recognized by your system, your computer first. Then your console can bring it up in the menu, so you may choose those. Okay. All right, let's go to a demo. Hello, this is a HackRF1. I'm not sure you can see it. And then there is this, signals coming in. Right now, there's no transmission, no receiving. So those two lights off and all others on. And this is antenna. So I'm going to attach the antenna here. All right. This is connected to my Windows systems through USB. So I'm going to run the SDR console. All right. So we have SDR console version 5.0.15. So launch it. And I'm going to choose HackRF or RTL dongle is also possible. And the bandwidth that you can choose, the bandwidth for example, Wi-Fi or cell phones, 20 megahertz may be okay. So start, and then I'm going to bring this, put this aside, and then currently this is 2.4 gigahertz. If as you move your mouse here, then there is an upper bar and lower bar. If you click the upper bar, then it goes up, it goes down. Same thing here. So if you want to see 2.4 gigahertz exact, then somewhere here, right? And then there's some menu here that you can play with. And the one that I want to show here, this is for zoom of the signals, so that you can see particularly, hey, right now this is running, right? Or you can, if you want to take a look in details, then you can zoom in and zoom out. Let's first start with the zoom out. And then that is the level of the decibels. So we can see it. Same thing here. You can choose it, right? So what I am going to do, for example, if I want to use some of the things, this is Wi-Fi, right? So let's say youtube.com. They type it, right? So I'm not sure this is will survive. Okay, let's run this. Okay, see if there is any area that you can see somewhere. This is the area that this Wi-Fi is using currently, or this, right? So if you want to see here more details, then you can see what you can do here. You can zoom a little further. You can see some of the signals coming in. This console, we do not know what that data is, right? But you see there is some very active signals coming in and going out, right? So this is what SDR can do. But if you would do some programming, it could be much more controllable. Okay, I think this gives you some idea. So you can receive some of the AM and FM radios if you like. Let's see if we have. Let me close this, and then AM radios. This should be down. What could be the AM? If it is not some of the signals here, right? You can chase it and see some of the signals. Let's see some of the signals that we can hear, but depending upon the encoding and decoding, we may not hear it clearly. I'm trying to see some of the. This is AM. We have more the signals clearly from FM, right? PFM, NFM, and WFM. For FM, I think I need to see the frequencies, channels, but I wanted to play with it. Okay? Thank you.